This chart shows the population of Cornwall from 1950 to 2010. So the population is how many people there are living there. In which year did the population first reach 400,000? So we have population here, and if we find 400,000, what we can do is draw a horizontal line across from that to where it meets the line of our line chart. Then we can draw a line straight down, because we have the year down here. Now we can see that it's right in the middle of 1970 and 1980. So the year must be 1975. You'd also get the mark for 1974 or 1976. Now, how much did the population increase from 1950 to 2000? So if it's asking what the increase is, it's asking how many more. So it's asking us to find the difference. If we look up from 1950, we can see that our line is halfway between 300,000 and 400,000. Then, if we look up from 2000, we can see that our line is on 500,000. So, halfway between 300,000 and 400,000 must be 350,000. So we can work out 500,000 minus 350,000 because we want to know the increase. So we want to know the difference between these numbers. And when we find the difference, we subtract. So our answer is 150,000 people. Now an answer of between 130,000 and 180,000 gets you the mark. Now, what was the population of Cornwall in 2010? So here we need to look up from 2010 and then we can draw a line across. We can see that our line is between 500,000 and 600,000, but this time the line is not right in the middle. I would say that it's closer to 500,000 than to 600,000. So here a good estimate would be 525,000 people, because if we imagine a line right in the middle is going to be 550,000, it's definitely less than that, but definitely more than 500,000. So here an answer of between 511,000 and 549,000 gets you the mark, because you have to recognise that the line is less than halfway up, so less than 550,000. Here is part of the morning bus timetable from Winton to Yansley. So we have Winton at the top and Yansley at the bottom, and it's important to understand what these columns are different buses that leave Winton at different times. So how many minutes does the bus take to get from Ingham to Dudley? Well, let's find Ingham and Dudley. And we could use any of the buses for this, but sometimes it's just easier or more simple to use the first bus. So we want to know how many minutes the bus takes, so we need to find the difference between these times. So we leave at 9:45. Now to get to 10 o'clock, that will be another 15 minutes, because there are 60 minutes in an hour, and 45 plus 15 is 60, so takes us to the next hour. Then, if we add on another 23 minutes, that takes us to 10:23, so takes us to the time it reaches Dudley. So altogether, the bus has travelled for 15 minutes and then another 23 minutes. So if we work out 15 plus 23, that tells us that it takes 38 minutes altogether to get from Ingham to Dudley. And notice also, if it's 10:05 and we add 38 minutes, that takes us to 10:43. And perhaps it would have been easier for us to use this bus here because we don't need to cross an hour boundary. Now Megan is in Carston. She wants to be in Yansley before 11:30. What is the time of the latest bus she can take from Carston? So let's find Yansley, and she wants to be there before 11:30. So if she gets there at 11:35, that will be too late. So she needs the bus that gets to Yansley at 11:15. But it asks the time of the latest bus she can take from Carston. So our answer isn't 11:15. Instead, we need to move up and look at the time our bus leaves Carston. We can see that it leaves at 10:21. So notice we're finding the time she needs to get to Yansley by, and then looking up to see what time it leaves Carston. And it leaves at 10:21. So the time of the latest bus she can take from Carston is the 10:21. If she takes the 10:41, then she would be late getting to Yansley. Write these numbers in the correct places on the diagram. So we have 5, 6, 7 and 8, and we need to decide whether these numbers are factors of 30, factors of 40, factors of both 30 and 40, so that would put them in this middle section here where the two circles overlap. Or if we write the number on the outside of the circles, that means that the number is not a factor of 30 or a factor of 40. So first let's take the number 5. 5 is a factor of 30 because 30 is in the 5 times table, or because you can divide 30 by 5 and you don't get a remainder. And 5 is also a factor of 40 because 40 is in the 5 times table. So 5 needs to be written in this middle section here where the circles overlap, because that shows that it's both a factor of 30 and a factor of 40. Now let's look at the number 6. 6 is a factor of 30 because 30 is in the 6 times table. But 6 is not a factor of 40 because 40 is not in the 6 times table. If we divide 40 by 6, we'll get a remainder. So 6 needs to be written in this section here to show that it's a factor of 30, but it's not a factor of 40. Now we have 7. 7 is not a factor of 30, 30 is not in the 7 times table, and 40 isn't in the 7 times table either. So 7 needs to be written on the outside of the circles. Then we have the number 8. Now 8 is not a factor of 30, 30 is not in the 8 times table, but 40 is in the 8 times table, because 5 times 8 is 40. So we need to write 8 in this section here to show that it's a factor of 40, but it's not a factor of 30. This scale shows the weight of Fred's cat. What is the weight of Fred's cat? Well, we can see that the arrow on the scale is pointing between 4 kilograms and 5 kilograms. Now, lots of children make the mistake of writing 4.2 kilograms because these children see that it's 2 lines after 4. But we can only do that if each line is a tenth. And here we have 1, 2, 3, 4, 5 lines, not 10 lines, to get from 1 kilogram to the next. So, because the arrow is pointing to the second line and the lines are not tenths, they're fifths, we have 4 2/5 of a kilogram. Now, if we want to write our answer as a decimal, we need to change those 2/5 into tenths. We can do that by finding equivalent fractions. So because 2/5 is equivalent to 4/10, we can think of 4 2/5 as 4 4/10, or 4.4. This 4 tells us that we have 4 whole kilograms, and because we have 4 tenths, we have 0.4, because our first decimal place value is the tenths place. Now, this scale shows the weight of Fred's dog. How much more does Fred's dog weigh than his cat? So for this question, we need to find out how much Fred's dog weighs. Then we need to find the difference between the weight of his dog and the weight of his cat. Now here, again, we have 1, 2, 3, 4, 5. So because it's 3 lines after 5, we have 5 and 3/5, because it's the third line, but we have 5 lines altogether to get from 1 kilogram to the next kilogram. Again, we can convert 3/5 into tenths. That's equivalent to 6 tenths. So because we have 5 kilograms and 6 tenths, we have 5.6 kilograms. But that's the weight of Fred's dog. So that's not our answer, because we want to know how much more does Fred's dog weigh than his cat. So we need to find the difference between 5.6 and the weight of his cat. So that's 4.4. We can subtract using column subtraction, or perhaps we could do this mentally, but that gives us 1.2 kilograms as our answer. Because Fred's dog is 5.6, but his cat only 4.4, that's a difference of 1.2. Match each box to the number which has the same value. One has been done for you. So we need to match fractions and decimals. So to do that, we need to remember place value in decimals. The first digit after the decimal point tells us how many tenths we have, and the second digit after the decimal point tells us how many hundredths. So to match fractions and decimals, what we need to do is find equivalent fractions which have a denominator of 10 or 100, because tenths and hundredths are our decimal place values. So first we have 3/4. Now we can't change 3/4 into tenths because 10 is not in the 4 times table. 10 is not a multiple of 4. But 100 is a multiple of 4 because 4 times 25 is 100. If we count 4 25s, we have 25, 50, 75, and then the fourth multiple of 25 is 100. So when we're finding equivalent fractions, what we do to the denominator, we need to do to the numerator as well, and 3 times 25 is 75. So we need a decimal which shows 75 hundredths, so that's 0.75. Then 1/2 is the same or equivalent to 0.5. That's because 1/2 is the same as 5 tenths, and remember the first digit after the decimal point is the tenths digit. So now we have 4/5. Now 10 is in the 5 times table, so we can find an equivalent fraction to 4/5, which has a denominator of 10. 5 times 2 is 10, and 4 times 2 is 8. So 4/5 is the same as 8 tenths, so that's the same as 0.8, because this 8 after the decimal point tells us that we have 8 tenths. The table shows the cost of coach tickets to different cities. What is the total cost for a return journey to York for 1 adult and 2 children? So because the journey is to York, we're looking at values underneath York. And we want a return journey for 1 adult, so we can find adult, then return, and if we go across to underneath York, we can see that that's £28.50. We also need the cost of a return journey for 2 children. So if we look at a child return and again go across so that we're under York, we have £17.90. but that's the cost of a return journey for one child, and we have 2 children. So we need to multiply £17.90 by 2, or add £17.90 plus £17.90. We can do that using column multiplication, and that gives us a cost of £35.80. So that's the cost of a return for 2 children. Now we have an adult as well. So if we add the cost of 2 children plus the cost of 1 adult, that will give us the total cost. Remember, if we're finding the total of different costs or different things, then we need to add. We can use column addition for that, and we get £64.30. Now, how much more does it cost for 2 adults to make a single journey to Hull than to Leeds? So here, because the question is asking how much more, we're comparing 2 different values, so we need to find the difference. So we're going to need to subtract. But first of all, let's find the cost for 2 adults to make a single journey to Hull. We can see adult single, and if we go across to under Hull, we can see that that's £12.50. But that's the cost per adult, and we have 2 adults, so we're going to need to multiply that by 2. Then we also want the cost to Leeds, so if we find an adult single and go across to Leeds, we can see that that's £10.25. But remember, this table shows the cost per adult, and we have 2 adults, so we're going to need to first multiply both of our values by 2. £12.50 times 2 is £25, so that's the cost for 2 adults to make a single journey to Hull, and then £10.25 times 2 is £20.50, so that's the cost for 2 adults to go to Leeds. Now remember, the question asks how much more, so we need to compare or find the difference between these values. So when we're finding the difference, we subtract, and if we do that using column subtraction, we get £4.50. Write the missing fractions. First, we have 4/11ths plus 3/11ths plus something equals 12/11ths. So here, the denominators of the fractions we're adding and our answer are the same. So 11 will also be the denominator of the fraction that we're adding. So now, looking at our numerator, we have 4 plus 3 plus something equals 12. Well, 4 plus 3 is 7, and then 7 plus 5 is 12, so our missing fraction is 5/11ths. Now, 3/5 plus something minus 2/5 equals 7/5. Again, our denominator will stay the same, so 5 will be our denominator, and then we have 3 plus something minus 2 equals 7. So before we subtracted the 2, we would have had 9, and 3 plus 6 is 9, so our missing fraction is 6/5. 3 plus 6 is 9, minus 2 is 7, and our denominator stays the same. Here is part of a number line. Write the number shown by the arrow. So we can see that the arrow is after 7,000 but before 8,000. Now some children write 7,100, but we can see that each line can't represent 100 because we don't go 7,000, 7,100, 7,200, 7,300, 8,000. So what we can do to see what each line represents is spot that we have 1, 2, 3, 4 jumps to get from 1,000 to the next, so from 7,000 to 8,000. That's a difference of 1,000. So if we divide 1,000 by 4, we get 250. And you can do that mentally if you know And you should know that 100 divided by 4 is 25, so 1000, so 100 with a 0 on the end, divided by 4 is 250, so 25 with a 0 on the end. So because the arrow is pointing to the first line, that means that we have 250 more than 7,000. So we have 7,250.